All right, so standard form for a quadratic, y equals ax squared plus bx plus c. All right, this is basically, you think of it as factored form, okay? Highest exponent to lowest. So here's our equation that we're going to graph, y equals x squared minus 4x minus 5. So standard form, again, is different than vertex form. Vertex form has the parentheses, okay? Y equals a times x minus a squared plus k. All right, so standard form. The first thing you want to do when graphing in standard form is state the a, the b, and the c value. All right, we're going to use a lot of those, well, most of them, all of them. So a is 1, b is -4, c is -5. Okay, a, b, c. All right, now to get the axis of symmetry when it's in standard form, we're going to use this formula right here. X equals -b over 2a. Yes? Yeah, -5. I said -5. -5. Thank you. All right. So this x equals -b over 2a comes from the quadratic formula. Okay, here's the quadratic formula. X equals -b over 2a. So this formula right here will get us our vertical line, okay, the axis of symmetry line. So you're just going to plug the a and the b value into that formula and you simplify it. That's step one, always. All right, so x equals -4 over 2 times 1. Okay, 4 over 2, 2. All right, so practice writing the axis of symmetry equation. Line out x equals 2. Again, make sure you write x equals. All right, and then as we find this stuff, we can graph it. So we're going to draw a vertical line through x equals 2. Okay, so this line is cutting our parabola in half. All right, so that means the vertex of our parabola has to fall somewhere on this line. Now, vertex we're going to get by taking that x value that we just found, that is x for the vertex. Okay? Now, to get the y value, which is going to tell us how high to go on this line, you're going to take that value that you just found and plug it back in for x in the original problem and solve for y. All right, so y equals, use parentheses, 2 squared minus 4 times 2 minus 5. Okay, so again, we're just substituting this value in for both x's. Now it's just order of operations, PEMDAS, simplify it down. That's going to be 4 minus 8 minus 5. 4 minus 8 is -4. -4. -4. Minus 5, -9. So the y value is -9. So we're going to write our answer again as an ordered pair because it's a vertex. So the answer would be 2, comma, -9. 2, -9. All right, so then on our axis of symmetry line, we're going to put a dot at 2, -9. 2, -9. It's down here. All right, just like vertex form. Now everything else is pretty much the same. We want to know direction of opening. Since A is positive, it's +1, we know the graph is going to be opening up. All right, so we know it has that shape going up. Now we're going to use that A value to find 2 points on our graph, counting from our vertex point that we just graphed. Since it's going up, now A value is 1, just put it over 1 as a fraction so you can see it. So from here, we're going to go up 1, left 1, up 1, right 1. Okay, so our A value is 1 over 1, think of it that way. All right, so there's 2 points. Then we're going to find the y-intercept. So to find the y-intercept again, just plug 0 in for x and solve for y. So one thing that's nice about standard form, the y-intercept is the least amount of work. So I'll show you why. Well, 0 squared is 0. 4 times 0 is 0. Minus 5. Negative 5. So the y-intercept will always be the c value. Okay? Always. So that's, in standard form, this is the advantage over vertex form. Vertex form, you have to do some math, order of operations, plug 0 in. Right? In standard form, you really don't have to do anything as long as you understand it's always the c value. Because this stuff will always go away once you plug 0 in. Okay? All right, so we plot the point on the y-axis at -5. We use symmetry to get another point, so reflect it over that line. So it's 2 units away, so we'll go 2 units in the opposite direction, or reflect it over. And then that looks pretty good. We got 5 points. Connect them. There's our parabola. All right, and then just so we can practice again, state the domain and the range. So what's the domain for this? Yeah, good. Remember, it's always going to be the same for this, for parabola. And then the range is what? Good. -9 to positive infinity. All right, so for each of these, we're going to answer each of these questions given the equation. All right, so number 1, what's the direction of opening? Up, good. Leading off with a positive. All right, so we can see A is 1, B is -10, C is -5. You should already see the y-intercept. It's -5. It's always the c value. Always, always, always. All right, axis of symmetry, we're going to use x equals -b over 2a. So we'll plug those numbers in. So that's -10 over 2 times 1. 10 over 2 is 5. So x equals 5. Now, as soon as you get the axis of symmetry number, just plug it into the x position for the vertex, because they're always going to match. All right, now to get the y, just plug 5 in for x in the original problem. All right, so again, this number is going in for x. Solve for y. All right, so 5 squared minus 10 times 5 minus 5. All right, so 5 squared is 25 minus 50 minus 5. 25 minus 50 is -25, minus 5, -30. So the vertex is at 5, -30. And we already have the y-intercept. Again, if you don't see it, plug 0 in for x, solve for y. Just like we plug 5 in for x, solve for y. All right, so let's do 2. Direction of opening, up or down? Down. All right, we can already see the y-intercept. What's the y-intercept? 6, good. All right, x equals -12 over 2 times -3. -12 over -6 is +2. X equals 2. Plug 2 in for x in the vertex. All right, now we'll just take 2 and plug it in for both x's and use order of operations to simplify it. So y equals -3 times 2 squared plus 12 times 2 plus 6. plus 6. Negative 3 times 4. Remember, you have to do 2 squared first before you do negative 3 times 2. Okay, plus 24 plus 6. Negative 12 plus 24 plus 6. 12 plus 6, 18. So the vertex is 218. If you have a calculator that puts all your numbers on the screen, and you know how to use the parentheses, you can type it in exactly like this, and it'll work it out. You're not sure on the order of operations? You can just type it in. All right, so now let's go ahead and graph both of these, just like the front. So A is 1, B is negative 6, C is negative 1. Y-intercept is negative 1. Okay. X equals negative B over 2A. All right, plugging 3 in for X. All right, let's plot. All right, X equals 3. Vertex at 3, negative 10. All right, the graph is pointing up. So we're going to go up 1, left 1, up 1, right 1. The y-intercept is negative 1. Use symmetry. Let's see, 1, 2, 3, 1, 2, 3 units away, so we're down there. Connect them. That's it. Yes. Oh, stretchy. Okay. All right, number 4. Dun, dun, dun. All right, A is negative 2, B is 8, C is 1. Our y-intercept is 1. Right, so the vertex should be at 2, 9. That's all this. Where are we at? X equals 2. 2, 9. All right, our A value is -2, so we're going to go down 2, left 1, down 2, right 1. All right, our y-intercept is +1. Use symmetry, get another point, connect them. All right, so the last thing I want to talk about is finding x and y intercepts given the equation in standard form. All right, so anytime we want to find intercepts, all you're doing is plugging 0 in for one variable, solve for the other. Plug 0 in for one variable, solve for the other. So, again, if you want the y-intercept, plug 0 in for x, solve for y. If you want the x-intercept, plug 0 in for y, solve for x. So the y-intercept's easy. Again, if you just plug 0 in for x, okay, you're just going to get everything go to 0 except the constant term. All right, now to get the x-intercept, we're replacing y with 0. Now to solve for x, we've been working with 3 different methods for solving. Okay? Now, the idea here is to use factoring if you can. If you can't factor, then you would probably just go to the quadratic formula. Okay? All the problems that I give you should factor. So since we have 3 terms, we would use the x method. All right, so -6 would go on top, -5 would go on the bottom. We need 2 numbers that multiply to -6 but add to -5. -6 and +1, good. All right, those are the factors. Those are not the x-intercepts. Those are just the factors. Now, to get the x-intercepts, we can set those factors equal to 0 and solve it. Okay, so we're looking for the solutions from the factors. All right, so if we set x - 6 equal to 0 and solve it, you're going to get x equals 6. And if you set x plus 1 equal to 0, you're going to get x equals -1. So the x-intercepts are 6 and -1. So now we can plot all that stuff and then sketch the parabola. All right, so we have a dot at -1 on the x. We have a dot at +6 on the x. All right, and then the y-intercept is -6. So it's on here at -6. And we should see from the direction of opening, along with those points, how to sketch it. So it should look something like this. Right? So this sketching with x-intercepts and y-intercepts is going to be really important in Unit 3. Right? As long as we know the x's and the y-intercept, and we know what the shape looks like, then we'll be able to graph anything. All right, so let's do this last one. All right, so the y-intercept we can see is going to be +12 because you put 0 in for all the x's. Everything goes away except for the c value, which is 12. All right, so to get the x-intercepts, we're replacing y with 0, solving for x, which means we're going to try to factor this. It's a trinomial, so we use the x method. Now, if I was you, not that you have to do it, but if I was you, I would get rid of the negative. It's easier to factor if it's a positive x squared. How do we get rid of the negative? Factor the negative 1 out. Okay, we can see negative 1 as a GCF, greatest common factor. So we can factor negative 1 out. And by pulling negative 1 out of all these terms, all the signs will change to their opposites. The idea is to get this to be positive. Right, so if I factor a negative 1 out, I'm left with x squared minus x minus 12. Now I don't have to deal with this negative 1 anymore because it's not going to have anything to do with the solution. Okay? I just have to go off to the side, use my x method, and factor that. All right, so I'll just do it right here. Negative 12 on top, negative 1 on the bottom. Two numbers that multiplied negative 12 but add to negative 1. Good. All right, negative 4, 3. Those are my factors. X minus 4, x plus 3. Set those equal to 0. Solve it. You get x equals 4, x equals negative 3. So those are the x-intercepts, positive 4 and negative 3. Now, some of you are asking, well, couldn't I just factor it the way this is without pulling the negative 1 out? Yes, you could, right? You would just have to remember multiply negative 1 times 12. You get negative 12 on top, the positive 1 on the bottom. So you find two numbers that multiply to negative 12 but add to 1 would be 4 and negative 3. But then, because you're leading off with a number that's not positive 1, you have to divide those two numbers by negative 1. So that's an extra step you have to do. All right, so let's plot all that stuff, connect them. All right, so positive 4, negative 3, positive 12 on the y, up there somewhere. We're leading off with a negative, so we know the graph's facing down. So easy. All right, so as you answer these questions, what I would do if you're referring to the notes, turn it over to the front page. Look at that first example, how we walked through to find everything. Always start with x equals negative b over 2a. X equals negative b over 2a. There's no factoring involved on this homework assignment. So don't factor.